What do you miss me, dude? I'm right here. Oop, oop, oop. This is the Wednesday stream. My bad. I didn't need to update the title.
I'm so sad, man.
Why are you sad? Why are you sad? Tell us why you're sad.
I didn't get to play Roblox with you.
Oh, I played Roblox on Saturday. Yeah, you should come by,
I
dude.
had to go to my parents on Saturday.
Oh, it's okay.
Yeah.
Hello.
What's up, Ethan? We played Jackbox on Sunday too. Were you around on Sunday?
Me?
I come back at 9 on Sunday.
No, unaccessible. Okay.
Okay.
Sorry, I haven't
Gotta
eaten
go
like
to,
eaten today, so I'm like kind of eating on stream.
That's kind of funny though.
What's up, Monkey? Good to see you, dude. Yeah, you did win. You did win.
That's dope.
Nice.
What do you win?
He won 1,000 V-Bucks.
You won 1,000 V-Bucks.
Yeah, dude, we love that dude. Nice, dude.
Yo, mister, I have an impossible question for you that you can never answer.
Is it one of those fucking Roblox questions again? Or the Minecraft question you had?
No. Nope.
Just
It's a
spilled water
really
all over
impossible question you can't answer.
I
Can I get... It's a multiple choice question. It's can I get Nitro? Okay, I'll tell you the answers from A to D.
Okay. What is it?
A is okay, B is yes, C is absolutely, and D is of course.
And there's none of the above?
There's no none of the above. It's just A, B, C.
Well, hey,
C, and D.
so I do give out Nitro every week. On Friday, we're gonna have a golden hour. I'm gonna start this with special guests. We have a special guest for Friday. We do.
All right.
Yeah, he's a video games tester. He tests video games. You know when you guys say like, "Oh, I want to be a video game tester," this guy actually is a video game tester. And he's worked on titles such as Halo, Warzone, Modern Warfare 2. He's a cool guy. I went to college with him at UT. He got his degree, I think, in like biomedical engineering. I got mine in physics. And then, we did our own things in life, and he ended up working as a manager for a video games testing company. Pretty cool. So yeah, we got some collabs. So yeah, I'll announce that in the stream. I had to double check to make sure he had time on his schedule for Friday, but he said yes. So I'll get that announced at the end of today, and then I'll have you guys submit questions, and we'll do the whole best question gets free Nitro or something, or maybe I'll do two gifts. Maybe I'll do Nitro to anyone who's in the stream gets entered, and then the best question will give out like a $20 gift card or something. Wouldn't that be kind of cool?
So should I enter the stream 6 times using my account?
No, don't use any alts, please.
All right, no alts, no alts.
If I catch you using alts, you get banned. Don't do it.
I get banned.
Well, you just lose your prize. You don't get banned, but you get put on my shit list. Don't do it. No. Yeah. I remember one time Obama used an alt to win a prize, and I was a little disappointed, but he apologized afterwards.
Come on, Obama.
He went from biomedical engineering to video game testing. The best question should be yes, exactly. Yeah, no, I will do that. I will have the best question picked by him. Yes, very cool.
So
I'll do that.
I'm gonna ask the question that he wants to hear, and he's gonna choose me.
Well,
as the
yeah, you don't know him. You don't know him. But yeah,
Hopefully-
hopefully Penn Center, we can get you for next Friday. I would love to have you on here. Trying to get more. This is what I want to do. I want to kind of like alternate it. I'll do like something more science, math based and whatnot, and then something just like kind of out of left field. So video game tester, I feel like is kind of out of left field, but also it's very related to our Discord. We have a lot of gamers here. We have a lot of people that play these video games, and plus this guy did go to college and did do an engineering degree, so it kind of shows you can do anything with your degrees. But yeah. Yeah, it's cool.
I already got my question prepared for. I already got my question prepared for Friday.
Okay, for Friday, cool. Yeah, I'll create a thread. I'll create a thread today or tomorrow. You guys submit the questions because I'll have him look at them ahead of time just so he can kind of be prepared for you guys. And then you really can become anything. Penn Center says, "I'm a farmer now." Are you? See, this is what I want to hear, Penn Center. This is why I need to get you on because I need to like interview you in your life. I'm actually very, very curious to hear about this. You can become anything, Yeah, I mean, I'm a person obsessed with gold who throws desert raves and, I don't know, teaches kids math and science on Twitch, so. And people are like, you have a PhD in physics? And I'm like, yes, that's true. I did do that at one point. Anyways. All right, let's start off the stream. All right, welcome everyone. It's Office Hours. My name is Dr. Cole with Actual Education, the stream that helps you out math homework, science homework, all sorts of fun stuff. Are you guys already submitting the AMAs? No. There's no questions yet. No. That's not the thread yet. Don't worry. There will be an official thread. I'll put one up. Yeah.
Guys, you guys are about to hear every time you finish something, I'm gonna play some for release for you guys. You know, just something.
Oh yeah. Oh, are you gonna do that? Are you gonna be our was it our end music like question thing?
Yeah.
I'm down. I appreciate you showcasing our talents. There you go.
So,
You know what this reminds me of, Unaccessible? One second, Ethan. This reminds me of if you ever like see on, I don't know, like the what's that guy's called? Jimmy Fallon or something? Jimmy Fallon show band. Yeah, like they always have this band on the TV show that always, you know, like plays music or something while things are happening. I think that would be cool on a live stream to have you know, have someone like playing music whenever someone finishes a question. I don't know.
Yeah,
I'm all down for like supporting the arts.
I'm gonna play drums with my left foot, play piano with my right foot, guitar with my left hand, and saxophone with my other hand.
Oh, that's cool. That's dope, dude. That's dope. Let's see. Oh, did someone help Kaz? I think Noise helped Kaz. Yeah, what's up, Ethan? What's up, dog?
So so tomorrow is gonna be my math exam, all right?
Okay. Nice.
And there's one last topic I want to cover.
Okay. Can you write what can you write what the topic is, take a screenshot of it and post it in the screenshots channel or something?
Well,
That's the best way for What's up?
That's not gonna be like a question.
It's okay. Just put it in there just so I can see it. That's the only way I can keep up with when people submit all these questions. That's the only way I can keep up with like who I'm working on next is I go through that channel. So it's okay. It doesn't have to be an exact question. Just post like a screenshot of I need help with blank or something and I'll get to it. You know, it's okay.
All right.
Let me how about Bob? Bob's first up on deck. Simplify the expressions. Ooh, I like these. We got some inverse trig functions. This is, you know, this involves a little bit of geometry, Penn Center. Isn't this your favorite? I think it is.
Very difficult.
No, this shit's easy. I'll show you. Okay. Oh, you need help with number 10? Oh. Oh, this thing. So you know how to do it here and you know how to do it here, right?
No, I don't.
Oh, you don't? Okay, whatever. Let's...
Number 10 is what I have to do.
Okay, but do you know how to do number 8? You should know how to do number 8.
No, I don't know.
Okay, let's show you. Okay. So, inverse trig functions here, like sine to the -1, always kind of weirded me out. But all they're really saying is sine to the -1 of x. Let's say sine to the -1 of x is equal to y. What's that saying? What that is saying, right, is that the sine of something is equal to x.
Yeah.
Exactly. So the answer I'm getting is, you know, like what angle is this? That's what I'm trying to solve for. I'm trying to solve for like what angle this is, right? Okay.
Yeah.
So, I like to draw like a right triangle. Yeah, Penn Center loves right triangles. We're big fans of right triangles. Right triangles are great. And so sine inverse of x, this x is here. This is an angle, right? And then I want the tangent of that.
So sine or cosine or...
Wait one sec. Usually it's just equal to something. Usually it's like, is it equal to like 3 or something, right? They want the tangent, inverse tangent of x. One sec. Oh, that's what I want to do. Yes, sorry. I'm dumb. I'm really dumb here. Yeah, okay. Yeah, sorry. Yeah. Sine inverse 1, right? Yes. Yeah. Is equal to y. Take the sine of both sides. That's what I'm doing. Yeah, it's backwards. I had it backwards. Okay, good. So x is equal to the sine of y. And then you do this. That's what we do. Okay, great. Okay. Yes. All right, my bad. See, I had to remember for a second too. Thank you, Penn Center. Thank you for catching me on that one. So this is the angle y, sorry. Yes, okay. And the sine is opposite over hypotenuse, right? So the opposite over the hypotenuse has to be that, right? X and 1.
Yeah.
And this is the angle y, right? And then you can figure out what this would be. What would this side be?
Square root of 1 squared equals 2. X
So-
squared plus that.
So yeah, it's square root of something squared, right? Plus x squared equals 1, right? So if you move that over, right, I get it's just 1 minus x squared
Mm-hmm.
is equal to square root of something squared. So get rid of that,
Oh yeah, yeah.
right? Okay. So yeah, this is 1 minus x squared. That's from the Pythagorean theorem. Okay, great. Okay, cool. And then I want to take the tangent of this, right? So now I'm taking the tangent of this angle, which is the opposite over the adjacent. So that's going to be equal to x over square root of 1 minus x squared. Right?
Yes,
Does that make sense? Yeah.
yeah.
I wonder if you have to like say like the domains and stuff, because like this technically has like some weird domains and ranges. Like inverse sine, I think, only pops out values from negative pi over 2 to pi over 2, right? So this is only from negative pi over 2 to pi over 2. Whereas inverse cosine is only has a domain from 0 to pi. So then your tangent values are only from negative pi over 2 to pi over 2, which, okay, that covers all of them, right? Opposite, adjacent. Yeah, you get all of them. Okay, whatever, that's fine. Okay. So then this one, right?
Mm-hmm.
Yeah, this is what I meant to say. So tan inverse 1 of x is equal to y is saying what angle, when I take the tangent of it, do I get x? So this is the angle y. And if I take the tangent of that, right, which is the opposite over the adjacent, I need to get x. So opposite over adjacent, right, x over 1. And then this is the square root of 1 plus x squared. So now the sine would be what? What would the sine of the same angle be?
Opposite over hypotenuse.
Good.
So x over thing.
Yeah, good. Yeah, excellent, dude. Cool. All right, where things start to get tricky is when we start putting like numbers inside the thing, like right here. This kind of sucks. We don't like this. This we're gonna use a double angle identity, I believe. I believe that's what we're gonna do. This is why you can't forget any trig. So wiki cosine double angle identity. I think so. I will check. And what is it for? It's for cosine of 2x. Which one is it?
I saw there was also a half angle identity.
There's a half angle one. Yeah. I want the double one. Which, I mean, you can use the half one for the double one. It works as well. Here we go. This is what you want. You want like one of these, right? Okay, cool. Oh, no. No, clear my clipboard. There we go. Okay, so I'm going to call this like cosine of 2y, where y is equal to the inverse tangent of x, right?
Mm-hmm.
And then did we do this already? We did this, right? Right? We did inverse tangent of x, right? Yeah, okay. So that's what triangle was that? I built it somewhere. Oh, I built it somewhere else, so it's okay. I'll just build it again. This is a lot of like building triangles. So opposite, adjacent, square root of 1 plus x squared. Cool. That's what this triangle is. And then this I'm going to simplify into, I could just do this one, right? 2 cosine squared of 2y. Or 2 cosine squared of y minus 1. So, does that make sense, right? Cosine of 2 theta, cosine of 2y is 2 cosine squared of theta. So, it's 2 cosine squared theta, 2 cosine squared of y minus 1.
Yeah.
Okay, cool. So now I do this. So now I do what the cosine of y would be. So now I look at this triangle. What's the cosine of y?
So adjacent over hypotenuse. So 1 over
Good.
the square root.
Good, exactly. So cosine of y is equal to 1 over the square root of 1 plus x squared, right? So then cosine squared of y, or not cosine of y squared, it's cosine squared of y. You square the whole result. So this is 1 over 1 plus x squared. So what you end up getting is 2 over 1 plus x squared, right? If I plug that in for here, minus 1, which, you know, we can simplify that again. 1 plus x squared over 1 plus x squared. What's that? 1 minus x squared over 1 plus x squared? That's kind of cool. I think that's right. Let's check. We can always check on Wolfram Alpha real quick. What was the question? Cosine of arc 2 arctan of x. Cosine 2 times arctan of x.
Yeah, it's right according to ChatGPT.
Well, don't trust ChatGPT, dude. ChatGPT is fucking bullshit,
No.
dude. For math, I think. I don't know.
The ChatGPT is just really an untrustworthy AI.
I mean, for certain things, for language models, it's okay. For anything involving numeric, dude, I told you I had a friend, or I had not a friend. Well, student's kind of my friend, but that was doing their chemistry homework and just threw it in the ChatGPT. Dude, half of it was wrong. I was like, okay. There we go.
Okay, then.
1 minus x squared over x squared plus 1. Yes, we'll take it.
Very hard.
Was that hard? You think that was hard?
Yeah.
Really? I don't think it was that bad. It's
A lot
okay.
of thinking.
It is a lot of thinking. I know. It's rough these days, thinking. Especially in January.
I was making.
Oh, we did. Unaccessible. Yes, yes. Play us out. Play us out for Bob's question, getting it right.
Hi.
Let's do it.
My parents are having a meeting. Never mind.
Okay, it's okay. Did they tell you, like, be quiet? All right, good job, Bob. Yeah, it's this is interesting that you're doing this in your calculus class, though. This is like a pre-calc thing, I feel like, right?
I don't know. Maybe it's a review.
Also, what the hell happened to the bot? Why can I not add bond coins now? What the fuck? Ugh. Okay. What the fuck? Okay, just remind me. Add 1 to Bob. I'll add 1 too. The bot's being weird right now.
Alright,
Okay.
Thank you.
You're very welcome.
That's okay.
What's
I
up?
posted what I needed help.
Okay, good. Nice. Yeah, let's go to the next one. Who we got? 5 reactions to this message and I'll do a hand reveal. Is that what you said, Jim Mark? What is this, dude? What you said 5? Let's see, where's my Discord not popping up? There we go. There, I got 4. Who's got the 5th one? Who's gonna get the 5th reaction on this so we can see the hand reveal? We need one more. Oh wow, we have 5. You have to do a hand reveal, Jamarcus, apparently. I don't know exactly what that means.
You want me to do that?
I mean, I'm doing hand reveals. Like, I'm doing everything reveals. Yo, thanks for the follow, Bandy. Appreciate that. Look at that. We're up to 625. Getting closer to 1,000. I don't know why 1,000's a cool goal. I think it's a cool number. What's up, Ethan?
Yeah, I did the 5th one.
Oh, nice. Love that. I regret it. The fuck am I do? I'm eating right now, so not right now. Okay, well. Fun time soon.
Okay then.
All right, I'm posting. Well, I forgot Jamarcus gives me like the most uber high resolution images ever. Jamarcus, I tried to post one of your images once in, I think it was Penn Center's Discord, and it said like 27 megabytes. I was like, what? Are you shooting like raw 30 megapixels on your camera or on your phone or something? Like, what phone takes a 27 megabyte picture? It's an old iPhone 12, but I don't know, bro. But like for whatever reason, dude, these things are 27 megs, man. Here, I did it on I'll show you. Well, we're gonna wait a minute for this to load, anyways. So, I forgot. I should always screenshot your stuff first, because here, look. If I save this image, and then here, let me see like what size it is. It's big. She's a big girl, dude. Oh, this one's not bad. This is only 4 megabytes. The other one was 27, I swear. I swear this one was like 27. Or you know what? Discord may like compress stuff when I download it. But yeah, look at this. Like what? Like I'm going into like the pixels. Another geometry prompt. Yes, Zach. We love geometry. We love geometry. I sent these to Danny actually on his stream yesterday. because I saw he was doing things with triangles. I was like, hey, Danny, you want to do some fun things? He also apparently like abhorrently like dislikes geometry. And I kind of agreed with his commentary on it. He said that geometry to him was as if there were a bunch of puzzles and you have to know this one little trick that unlocks the key or something. And I kind of agree with him because a lot of geometry to me is you can be the smartest person in the world, but if you don't know those little, like, oh, well, this is actually 180 or this is equal to this, you can't unlock it. That's why it's also kind of fun. Geometry to me is not so much math and more just like puzzles. A lot of puzzles. Which makes sense for Jamarcus being in this math Olympiad class, and these are the types of questions they're giving him because they're puzzles. Okay, in triangle ABC, median AM is perpendicular to angle bisector BD. Find the measures of all the angles if ABC is twice ACB. All right, let's draw some things. And then I gotta remember what mediums and bisectors and all these things are. This is all the definition stuff I talk about, where I'm just like, oh man. But you helped out a lot, Zach. You really gave me a lot of confidence on that last one. I'm slowly starting to get better at triangles and geometry. Okay, median AM. Okay, this is A. The median, I believe, connects to this side BC and cuts it in half, but isn't necessarily 90 degrees, right? It's like I think it's like this. And then angle bisector, cool. So angle bisector does bisect the angle. It connects a median of a side to the vertex. Oh, I like that. Yeah, okay. Yes, the median is the halfway point, which is, yeah, okay. It's not the average. There's no average of a line. Okay, and then BD, angle bisector. Okay, so I assume... Oh, fuck, that's weird. So they're saying... Oh, I gotta redraw my triangle because this is all right. They're saying this is an angle bisector, right? And they're saying if this is D, that this must be perpendicular. Okay, let me try to make this look realistic though, right? I think what I have to do is I have to bring this triangle over here, maybe. Is kind of what I have to do. Just so for my own sanity. I'm a visual learner. Okay, let's maybe try this. No, that's worse. Uh-oh. How does this work? Oh, this has to be on the left side of it. Okay, sorry, you're right. It's got to be this way. I think the triangle has to be more this way. Okay, okay, I think this makes more sense. Okay, good. All right, there we go. That's what I wanted. All right. See, I can't visually just see that. That to me oh man, wait, is perpendicular to the angle bisector B. How are these going to be 90 degrees? Well, I guess this is going to have to be... One sec. It's going to have to be something like this almost, but yeah, let's pull this triangle down maybe. Okay, I think I'm getting it. Okay. What a wacky ass looking triangle. Raid, what's up, Stucky? Good to see you, Ian Stucky. Yeah, we're doing geometry. We love geometry. Doing triangles. This is the question we're doing. Jamarcus is a part of this this math Olympiad competition type thing, and so they give him these really super hard geometry questions, which I know Danny loves. They're Danny's favorite. Danny loves geometry, right? Yeah, a little challenge problem. I like them. They're kind of puzzles. Puzzles. Okay, sweet. There we go. We got that. And we got that. All right. And now, find the angles. So we got to find all the angles of the triangle. And then they tell us that ABC. Where did the Discord chat go? Oh, my bad. Sorry. There it is. Sorry. My bad. There it goes. Yeah, thanks for for checking that, Jamarcus. Yeah, I do that because the Discord chat is a screen capture through Stages, because Discord still hasn't made it so that there's an OBS plugin for Stage chat to go into OBS. I don't know. They have it for regular VCs. They don't have it for or regular text channels. Okay, so ABC, which is this angle, right? So angle ABC has to equal 2 times ACB. Okay, cool. So that's this one. ACB. And we also know that this angle right here, the median AM, has to be perpendicular to the angle bisector BD. Yeah, there we go. Perfect. Okay. So this is 90. Okay. By volume we clearly do, yeah. Okay. Let's try to get some things here. This is the same as this, which I start to say I want like an isosceles or something. Or maybe like side angle side. Because this side, right, is also the same side. Okay, wait. I think I see something. Sorry. This is 90. Side. Oh, but we don't know something about this angle. I'm just going to guess it's a 45, 45, 90. It's not. It's unfortunately not. Yeah. Okay. Oh, okay. But I do know things about the angles. I know that this is twice this. So, okay. This is cool. So let's remember, right, that this line BD was an angle bisector, which means it cuts angle ABC in half. Okay? So, and since ABC is twice ACB, that means each one of these is the same as this. So, I'm actually going to label this way. I'm going to say, yeah, these are actually all the same. Ooh. We know angle BAC is 180 minus 3x. Yes, I agree with that, right? Because this is x, and this is x. Right, good. Right, yeah, okay, I like that. Angle BAC is equal to 180 minus 3x. And this I start to see like this is angle... No. So we just need to get x somehow. Okay. Okay, x plus 90 plus this is 180. What if I just call this? Let's call this like z. Okay. So x plus z, right, must equal 90. And then this is going to be 180 minus z. This is also a triangle. Yeah, fill in the other ones as well. Yeah, right. Yeah. So then this, right? This is 2x plus z plus this. So this is 180 minus 2x minus z. Yeah, okay, let's call this point O. I like that. Yeah, let's do that. That's a good idea, Zach. Yeah, let's call this O. 180 minus z is also 90 plus x. Where do you get that from? 180 minus z is 90 plus x. Where do you... Oh, exterior angle theorem. Oh, wait a minute. Oh, these are all 90. I know these are all 90. Oh, okay, wait. Yeah, you're right. We actually have another... We have another theorem here, right? This is another triangle. I like this one too. Yeah. Look at this one. So this is 180 minus 2x minus z plus 90 plus x. Wait, sorry. 180 equals... I'm really screwing up here, sorry. No, I had it right, sorry. 180 minus 2x minus z plus 90 plus x has to equal 180. Let's see if that, does that solve anything else for me? So that's negative x minus z is equal to negative 90. So x plus z is equal to 90. Is that what you said? 180. Well, 180 minus z is equal to 90 plus x. Yeah, okay, okay. Oh, we already said that. Oh, that's dumb. Sorry. Angle BAO. All right, let's see. Angle BAO. Yeah, x plus z plus... This is right. This is okay. We're okay with this one. Sorry, this was 180... Oh, I see, because I did this triangle is what I did. I did 180 minus 2x minus z. That's what this... If I do like this triangle here. And then... But you're saying BAO is... Right. That's also... okay. We start... There's so many triangles. This is x. Okay, let's say whatever this angle is, right? That's 90 minus x, right? Yeah, that's right. X plus 90 plus equals 180. Yes, this is also 90 minus x. There's a lot. There's a lot. 180 minus 2x minus z is also equal to 90 minus x. Okay. Does that help us though? Because if I add that, I think we just keep getting x plus z is equal to 90. Right? Negative x, yeah, minus z is equal to negative is wait. Let me move this over. X plus z is equal to 90. Yeah, all this just gets is x plus z is equal to 90. Yeah. Okay. All right. We need one more relationship then, right, between x and z. And then we'll be able to solve everything. Corona? What's Corona, dude? No, this is my x plus z is 90. Man, I need... This is also going to get this. Where's my other one? I think I have to use something with the sides being the same too, though, Zach, right? I think this is going to play a part of something. Because why would they tell me the median thing? Side, no. Let me write out what this is too, sorry. 180 minus 2x, and then it's minus z, so plus x minus 90. So that's 90 minus x. Yeah, this is also 90 minus x. Okay, good. I know that, yeah. When can a median be perpendicular to angle bisectors? This is 90 minus x. Maybe there's some weird theorem. Dude, that's all geometry, dude. Geometry is all like, there's some weird property of angle bisectors and medians being perpendicular. No, but also this puts an interesting condition on things. Oh, wait a minute. Okay, wait. Okay. BAC, right, we said was equal to this. I I almost want to introduce another variable. But every time we do this, we're borrowing against the bank because then there's another variable we got to solve for. But if I were to call this y, right, then 90 minus x plus y is equal to this, right? Is equal to 180 minus 3x. Because, yeah, that's what we said, right? These two added up to each other, right? 90 minus x minus y plus y is equal to 180 minus 3x. Let's just call this y, just for shits and giggles. Because then I think I can do something with this as another triangle. What does this get me? Add 3x, so that's 2x plus y is equal to 90. Okay. Yeah. There's another one. Okay. So now we have two equations. I need just one more equation. And then it's 3 equations, 3 unknowns, and we're okay. So what about this one? Let's see if this does anything. Does 180 minus z plus x plus 180 minus z plus x plus y equal 180? Does that do any good for us? It does. I think that does. I think that's it. Yeah, that's the missing part. Because then this goes away. Yes, okay. So x plus y minus z is equal to 0. Okay, cool. There we go. And I hope they're not combinations of each other. Yeah, right? Yeah, okay. Okay, so now I have a systems of equations. I could use these to eliminate, well, what does that get me? X plus z is equal to 2x plus y. Oh, we also got to hope the other one isn't a linear combination of the other one. Oh, which I do see that. These two do combine to form this one. Because I don't think we're solvable yet. If I put in like my matrix form. Right, this is 1, 0, 1, 90. And then this is 2, 1, 0, 90. And then this is 1, 1, negative 1, 0. Yeah. And I think you can see that this row, right, minus this row is just going to give you this row. This is why linear algebra is actually kind of cool to visualize this. Because then you can see, like, oh, this is just another combination of the other one. Let me see. I want to see what happens actually if I do that. 1 second. Where's my calculator? You gotta leave in 10 minutes? Okay. Well, I think we can get it in 10 minutes. We're close. We're super close. Oh, you have a research thing today. That's cool. Okay. Let me just see. I'm curious. What's up, Unaccessible?
Numbers underneath. The box containing numbers.
It's called a matrix. That's what it's called. And we're running a 3x4 here. I want to see. I'm pretty sure this won't work because one of them is linearly dependent on the other one. But maybe it does.
Oh, dude, I do not want to see me doing matrices.
Ian Stuckey was just doing matrices on their stream. That was pretty cool.
Really?
Yeah. Do it. See what happens.
When you guys finish, I'm gonna beatbox for you guys instead of
Okay.
playing piano.
Oh, because your parents said you can't play piano?
You never
Yeah,
seen
see? Oh, man. Yeah. Yeah, no, it doesn't work. Doesn't work yet. Yeah. See, this is the problem, Jamarcus, is that, yeah, this is literally what I was about to say, is that this third row here, this is a cool thing in solving systems of equations. This third equation we came up with, this one, is just a combination of these two. And so that doesn't provide any more information on how to solve for it. It would be the same thing if I was like, oh, look, I came up with 3x plus 3z is equal to 270, right? I'd be like, oh, I have another equation, but you don't, because it's really just a multiple of this. In this case, this is just adding these two. So this equation doesn't tell us any new information. All right. And well, wait a minute. Wait, these are all 90. Oh, wait a minute. These are all 90. I don't want to make this an angle. I don't really want to have to go for two of these. Because every time we introduce another variable, we have another equation we have to figure out. You got a crazy idea for this question? What is it? Tell me. Murder whoever made it? No choosing violence, dog. Come on.
It goes hard.
It goes hard, dude. Okay, one sec. I think we got it. Dude, come on. We got a triangle here. We have this triangle, and then we have this triangle. From those three triangles, we should be able to figure something. I think there's something to do with this. I almost want to use like law of sines or something. Because they are right triangles.
Isn't it like that last question where you had it was like a week ago. It was like congruent triangle, find the A, B, C, and then you realize you put the A, B, and C.
Oh yeah,
This is
yeah.
wrong.
Inscribed triangles. Yeah, I know what you're talking about. Yeah.
Isn't it?
I mean,
like-
it's
isn't it like that?
close. It's similar. What's interesting is I have in this triangle, right? I have a side and an angle, that are the same. I don't think that makes them necessarily similar triangles, though. In geometry, there's a bunch of ones you need. It's called like angle, side, side, and then side, and then angle. But you have to have them in like a row in order for them to be what do we call it? In order for them to be similar, and then the angles are the same. But let's think. I got 90 degrees. I need something to maybe be parallel. Because the other way is to introduce this as an angle that we're solving for, and then I get a quadrilateral that I can do 360 with, and then I can do this, and then I can do this, and then we're on the search for 4 equations I need. Yeah. Ugh. Wait. Side. No. No. Side Z90. Side not Z90. No, this should be solvable, dude. Okay, let me think if I used all the triangles I could. I used this one, right? We used this one. Right? 90 minus x plus z plus 2x, right? Did we use that one? 90 minus x plus z plus 2x is equal to 180? I think we used that one. Or maybe we didn't. Oh, wait. Okay, what about this triangle? That's... Oh, no, that's x plus z is equal to 90. We already have that one. Okay. Okay, that was this one. This was... Did we use this one? Well, that's what... No, that's what this one was. Yeah, that's what this one was. Okay, and then what about the big girl? What about the real big girl? The super huge one. So that was 90 minus x plus y plus 3x is equal to 180. Let's see if that solved anything. No, that's the 2x plus y is equal to 90. That's what that one is. Damn. Jamarcus, dude, you always hurting me with these. Your Russian math teachers inflict pain on me. Okay. We did this one. We did this one. We did this one. Is there another one? Oh. No, there's this. X plus Z is equal to 90. Same equation. There's this. Same one we did. Yeah, send me a screenshot if you figure something out. Okay, Siege Marcus. No, that's what this is. I don't know. I'm stumped. I'm stumped. This is how far I get. But we need one more equation. And I think it has to do with these sides being the same. There's some relationship with the triangles. It's something like, you know, let's just for shits. Let's do this. Let's just do it for shits. Let's say I call this like let's say I call this length L. Let's call it L. Then sine of y over L is equal to okay, wait a minute, maybe. Okay, wait, once I might see something here. Sine of y over L, this is law of sines, is equal to, let's say, sine of x over AM. AM is this median. Okay. That works for this triangle, for instance, all right? So then let's look at this one. So now I have the sine of 2x over AM, right? Over AM is equal to the sine of 90 minus x over L. Okay. Maybe this is what I need. Maybe this is what I need. Let's see if this does some shit for us. Man, that 2x and that x though, that's going to mess with things. What is sine of 2x is 2 sine x cosine x? Is that correct? No. Yeah, 2 sine x cosine x. Okay. So 2 sine x cosine x over AM is equal to sine of 90 minus x, right? Over L. And sine of x over AM is equal to sine y over L. Okay, so I can replace this. 2 sine y over L cosine of x is equal to sine of 90 minus x all over L. Okay, now the L's cancel. 2 sine y cosine of x is equal to sine of 90 minus x. Sine of 90 minus x, I believe, is cosine of x. Is that right? What is the identity for that? Just tell me it. Is equal to cosine. Yes, good. Oh, ooh. Ooh, I like this. I like this. We're getting somewhere. Okay. 2 sine of y cosine of x is equal to cosine of x. Cross, cross. Sine of y is equal to 1/2. Oh, my God. You fucking bitch. I got you. Dude, law of sines always like comes in handy sometimes. Okay, cool. That tells me something. Okay, if the sine of y is 1/2, that tells me right away y is equal to 30 degrees. Yes. Okay, cool. All right, now we're good. So if y is equal to 30 degrees, right, that means x is equal to 30 degrees. Right? Okay, cool. So that means angle C is equal to 30 degrees. Angle B is equal to 60 degrees. And angle A is equal to 90? Okay. Let's make sure that makes sense. So, Z would then be equal to 60. Does that make sense? 60 and X plus Y. X and Y are both 30. Yeah, okay, cool. 90, 60, 30. I think that's it. Okay. Holy shit. Jesus Christ. Wow. I was right, though. I was right on my intuition. I almost gave up there for a second. But then I noticed this thing about the median, and this is something you should I don't know, if you're doing these types of questions and you're kind of lost, start looking at the information they give you and think about how can I use that information to figure out something I don't know. And so the medians told me that this side was equal to this side. And so when I have equal sides, the only thing I really know about with triangles and trig and side lengths being the same, besides trying to do this type of stuff to prove they're similar, is I know that law of sines involves sides and angles. And thus, if I can get two triangles where I'm using that L side at least, and we're using similar variables for the angles, then I can do some funny manipulation to figure out what one of those variables is. So this was the beauty right here. It was right here. Yeah, I'm just gonna mark this. I think I was telling Danny this actually as well, because we were talking about solving triangle problems, and I was saying I just always brute force it with law of sines and law of cosines eventually. It does get the job done. So here I'm gonna say law of sines is our savior. Nick, can you stop DMing me on Instagram, dog? You're like blowing my phone up. You know I'm streaming right now.
I love you.
What's up? Oh my gosh. This law of sines is our savior. Yeah. This
I'm
one's
watching
hard. Yeah, you're watching what? What's up?
I was watching a video on how to do the sine rule and cosine rule.
It's good. Yeah, law of sines and law of cosines is great. Super useful. It saved us here, honestly.
I was actually able to figure out the sine rule perfectly. Just gotta figure out the cosine rule now.
Okay. Yeah, the cosine one is not as pretty. And it involves law of cosine. So law of sines, I think you need two sides and an angle. Yeah.
Yeah, it's two opposite sides. One angle and one that's opposite is a side. That's what it says.
Yeah. Well, it involves like two sides and two angles. Whereas law of cosines only involves all three sides and one angle.
Yeah, and see, look at the notes I have here. To find a side when you know the other two sides and use the angle between them, you use a formula.
Yeah, law of cosines probably.
I don't get that.
That's law of cosines. That's law of cosines.
Yeah.
Yeah.
Got another question to do?
I do have a couple. The paraboloid. One sec. Teacup's asking advanced calculus questions. Teacup! I haven't heard your voice in a bit. What's up, Teacup? Come up here. Come up the stage. Say hi.
I'm just gonna try and see if I can finish the video in time.
Okay. Yeah, finish the video. Yeah, then I'll get to you. You're good. Yeah, for everyone else who joined us from either Zach's stream or Ian Stuckey's stream and whatnot, welcome. This is our office hours series of Twitch live streams. We do these Monday, Tuesday, Wednesday at 3 p.m., 4 p.m., 5 p.m. Pacific. And these are mainly for helping students out with their homework questions. Or in the case of some students, they have advanced, Math Olympiad type things are in. And I bang my head against the wall to try and help them. So if you have any questions in any of your classes, tests coming up, you need some help to study, these are great.
From headbanging.
Hypatia is always here for the headbanging. We love that. Did you just see the question I was doing, Hypatia? Dude, I was banging my head for a very long time.
No, I was talking to Pen Center in another server, but
Oh, good. Yeah,
Pen
Pencenter's cool.
Center had a person asking about number theory. It's about the residue symbols. I like if you are interested in that as well.
Yeah, no, Penn Center gets so I would say the majority of my audience is middle school and high school kids. So you do get some people that go above and beyond and want the higher level topics. But from what I see on the other streamers, you know, Penn Center, Zach, Ian Stuckey and whatnot, they get some pretty high level math people in there, which is why I think you would really like flourish to talk with these people, because your ability to do math is above what mine is, and I think really would resonate with a lot of their viewership.
I mean, there's another thing. I was just reading about algebraic and functorial quantization, and also about the just like gauge theory or QFTs in general. I mean, you are a physicist, so we can start another stream series about physics, I guess.
Yeah, we can do some physics. Yeah.
Like you can I can talk about the theoretical stuff, and maybe you can fill
I
in
do more of the
the
hands-on
other
experimental type stuff. Yeah, I'm an experimentalist at
yeah,
heart.
for example, what inspired quantum electrodynamics? That's the abelian gauge theory.
Oh, is it?
Like
Abelian
you can
gauge.
start with that, and then you can fill in on the different kinds of experiments, the observations leading to the proposal of these.
You know what I like? I liked when Ramton did that one stream on like teaching me what group theory was. Just remember he kind of like did a real basic, like, these are what groups are, and this is what makes a set, and this is what completes things. I found that incredibly like
Wait,
informative.
really? You never learned about groups?
No,
when
no,
you're doing
no. Again, I was an experimentalist in plasma physics, so we didn't deal with
Oh yeah,
very
you
much.
code.
We're a lot of code, a lot of analysis, a lot of data, a lot of like fluid dynamics. I did a lot of fluid dynamics, but not very much in terms of super you know, theoretical stuff out there. Some people did. Page 355. What are we doing here? 355. Teacup is in the PDF, or is it yeah, 355 the PDF
Oh shit,
usually
I
is-
forgot to write that, like the last average thing for you.
Oh, yeah. Show it to me. Yeah.
Yeah, I forgot to write it.
It's okay. It's okay. I forget many things. I forget what happened 2 weeks ago. We have a joke in my friend group that if it happened more than 2 weeks ago, I don't remember it.
Okay.
It's okay. You're totally fine.
I'm gonna write it sometime.
This is cool. This is actually very relevant to what you were showing me on your notes for your calculus class. Hypatia. Finding the volume of a rotation region around something. It's kind of cool.
Yeah, I mean, somehow my course coordinator they decided to put in this thing for 4 whole weeks.
4 weeks of rotate
Yeah,
of volume of
for these
rotations.
kind of things, volumes, arc lengths, or just different kinds of weird things you compute with the integral. I mean, it just doesn't seem.
Wait, but how long is your
worth it.
class? How long is the class if they're spending 4 weeks on volumes of
I
revolutions?
think 15 weeks. Or
So a quarter
something
of the
like that.
class was spent on volumes of revolutions?
Not only this, it's not only volumes, surface areas, or
Uh-huh.
arc length, arc area, or things like that. So, I mean, I did some expansion on the area thing because it's more complicated, like the Schwarz lantern.
I think the reason why this probably got covered a lot of Hypatia is because when you set up these integrals, a lot of them have very interesting ways of solving the integral. So there's already the exercise of creating the integral to find the volume of revolution, and then there's the exercise of, okay, wait, but how do I even solve this integral? And this involves a lot of integration by parts or trig substitution.
Yeah, but they never learned the trig substitution. They just
Oh, you should learn that
remember
first. That should be like an advanced techniques of integration first, and then you
Yeah,
apply
they
it, right, in
just
order to use this.
recite it. They never know, for example, the Euler's formula thing I wrote.
Oh, really?
If you click on the LaTeX note, you will find the Euler's formula thing I wrote.
I should
But
sticky that thing you sent me. Let me find it one second.
I-
It was not the convolution one. What was it?
no, not that one.
I think it was this. I got it. I think I got it.
This one, yeah.
This one right here. This is it, right?
Yeah, but also you can go to home, like click on the title,
Okay.
and there's a link, like old notes. Old notes. There's a link to a Overleaf shared document.
I clicked on it. Oh, sorry, it's right here. Ooh, we love Overleaf.
And
This
then
is I wrote my whole PhD thesis in Overleaf.
Oh,
Yeah,
and not this one. There's a trig frac thing,
got it.
and then click compile.
Yep. Okay, cool.
Yeah.
Oh
seems
yeah,
like
you
this.
showed. Oh yeah, you showed me this at one point, and then
Yeah, but-
I gave you some tips on like what steps you should explain.
Yeah, but after that there is the Euler formulas.
Okay,
thing.
let's go. Let's
You
go.
remember it?
Let's go. Let's find it.
Yeah, I was no, the second page.
It's this, right?
No, above.
Sorry,
yeah,
there you
this one.
Aha.
Like I will offer a lot of times these more technical explanations if somebody is interested, and in fact there are people who are interested.
No, I'm interested. This was cool. One second. Let me pull
Yeah,
up the
so
PDF so people
I
can see it.
think this is more important than the second and fourth page is more important than the first and third page.
Right. This is trig sub, which is very useful. This is a useful technique. And then
I want to explain why.
yes, yeah.
specifically.
And I was talking about this actually with another streamer. I think it was Zach, or maybe it was Danny or Don or someone, but they had a similar problem where they were having to deal with weird trig stuff, sines and cosines. Oh, they were doing a differential equation. That's right. And I said, just decompose it into e to the ix and e to the x, because once you do this, a lot of the identities start to pop out just from rules of exponents.
Yeah, but they don't want to do it because they do.
I know they would rather
if you want to talk
memorize
about
like a
the
table.
complex- If you
Yeah.
want to talk about complex exponentials, you have to talk about analytic continuations or analytic functions.
I don't even know what
or-
those words mean. Analytic continuation? No. No. Okay. Where's Teacup? Let me tag Teacup. Where's Infamous Teacup? Where you at, dude? This is a good question. I gotta tag Teacup.
Yeah, well, anyways, I mean, right now I'm free to do whatever I want since I don't have anything.
I know
to do.
and I like so a little sneak peek at things. I may have a big prize that I'm picking up tomorrow for the students, which means I can start running another tournament coming up for the next couple weeks, and with that, we can have all these like side quests, these side challenges, and I'd love to have you like in charge of one of them. So maybe like an exploratory math challenge where students go through, something that you want them to learn or something you think is important for them to have in their repertoire for, whatever they're doing in math. And then if they go through it and they complete it and maybe show a screenshot of that they participated, then they get points for it. And then, it's a win-win situation. It gives you the opportunity to learn how to teach very complex concepts to kids who probably don't get it at first, and then it teaches the kids to like reach up a little bit more,
Yeah, I think now that I know how to code up the interactive gadgets, so
Yes.
we can try to do things like this.
Yes.
Although,
Yeah.
did you pay it yourself or did you get another funding?
It's actually there's a funny story of one of my like associates I used to work with was doing a giveaway for a PS5, and
Oh.
I bought a ticket for like $10 because just to support him. It was like a raffle. I just bought like a $10 ticket. I was like, I'll support you, dude. I'll support your raffle, and I ended up winning. So I won a PS5. I'm gonna see if it's real tomorrow. He said, yeah, come pick it up tomorrow. I'm like, okay. But if it is real, then that's a big prize that I know the students will go for. So I can feel confident with running another tournament because then I'm not paying. I mean, I only paid $10 out of pocket, but then I'm not paying my own rent money to incentivize kids. You know, we have a prize.
Yeah, that's
Yeah.
cool.
I hope so. I hope it's real. I hope the universe put this all in my right direction. Monkey says he wants a gaming
that's good.
laptop. Well, you know, if you win the PS5, you can always just sell the PS5. I don't care. I don't care what you do with it. Like, you can go give it to your friend and trade it for a gaming laptop. Yeah.
Honestly, I don't care. I'll just take the PS5.
I know everyone. It's a free PS5. Like, but let me go get it. Let me make sure it's real tomorrow. I don't want to get everyone's like super hopes up tomorrow. I'm getting it tomorrow, hopefully. Anyways, yes, Teacup, what's up? Let's do one of your questions. This is cool. It says find the volume obtained by rotating a region B in Figure 12 around the wait, what? Wait, oh, this is the wrong thing. My bad. Wait, where is oh, fuck. Okay, this is what I wanted. Sorry, I had the wrong thing here. This is the prompt. Yes. Okay, cool. Here we go. When's the next tourney? I will be announcing it soon. Hey, it's my favorite formula. Is this your favorite formula? This one or was it this one? The cosine. The Euler's formula. Nice. Yeah, Hypatia is that's another person you should talk to, Hypatia. Talk to E to the 2i pi. They're very cool. I need to have a shout out button. Like maybe I just need to like talk to all you guys. Like who's this Enigma person who has like a bot that does things in the Twitches? I think that's pretty cool. I have Nightbot running various things that I could do as well, but I'm also open to I feel like you have someone who's coding their own custom bot, which is cool. And probably has some stuff that would be useful. That I'd be curious to try it out. Okay, use the shell method to find the given volume relation, the paraboloid obtained by rotating the region between y equals x squared and y equals c around the y-axis. Yeah, okay, cool. That's cool. Yeah, it globally tracks saves in MathStreamer's methods. Yeah. Or is that what it does? Yeah. I have coding experience. I've coded plenty of stuff like in my life, but I don't know if I want to start going down the rabbit hole of learning how like shards and everything works on Discord. To math streamers' chats. Yeah, there you go. You got it. Yeah, okay. You're good. All right. Oh, I guess we're gonna have this variable in there. Okay. Y equals x squared. Teacup, are you in the VC? Where are you? Come say hi. I gotta teach you. Methods. Chats can be methods depending on what you're doing. Chat is a method for expressing communication or stuff. But okay. Y equals x squared. Everyone should kind of know what this looks like. If you don't yet, it's one of the nicer functions. It's the happy face function. So it just looks like this. This is y equals x squared. There we go. This is y equals x squared. And then we are rotating this about the y-axis. So the y-axis, let's remember, is going to be this one. So this is the y-axis. So we're rotating around here, okay? And, oh, and it's y equals c. Oh, okay. So that's just this. Okay. So this, this looks like the thing you had, Hypatia. Let me go find it. Where did I put it up? No. Did I? No, that's something else. Ugh. One sec. Let me find it. You had a one sec. You had a thing of it. I want to pull it out. It was very cool. Yeah, this is it. This is what I want to pull up. There you go. Why did this not save my cache? Yeah, there we go. Where was the volume of? Was it this? No. We were talking about laptops. Yeah, see, that's what I know. That's what gets your that's what piques your interest. I know that is.
So I heard talks about a laptop. I need
There
to
it is.
elaborate.
This is it. This is it. This is what we're doing. Volumes of Revolution. This is it. Yes. Okay. Cool. Yeah. Very cool. I like. This is very cool.
So real quick, can I get some elaboration on that laptop?
Oh yeah, I was saying that I may have a big prize for the next tournament. So I'm gonna find out tomorrow if it's real.
I'm probably not gonna participate that time.
Okay. I mean, you can. It's free.
I'll participate. I'm not gonna win though.
Well, not with that attitude.
Clearly, you gotta buy me a framework laptop.
Framework. What's that? I'll look at it later. Here, let's do your question first. Then I'll do.
It's actually really cool. Okay.
Okay, so we are creating. We're trying to find the volume of a shape. This ends up kind of looking kind of like a bowl. Is what this looks like. Looks like this.
A bowl.
Looks like this. It's a bowl. So imagine a bowl. That's what this looks like, because this is like the cross section, and then I just like rotate this thing around a bunch of times.
Yeah,
okay.
It's rotating.
Yes. Okay. So when trying to, this is the very cool thing about integrals, is that in order to find the volume, let's say the volume of the bowl. What is the volume of the bowl? How would you describe the volume of the bowl? It is a teacup.
How much cinnamon toast crunch can? Oh, it is a teacup.
Good. Yeah, how much stuff it can fill, like volume. All right, cool. Let's say cinnamon toast crunch, or yeah, it is a teacup. Yeah, okay.
Tea. How much tea can hold?
So one way that would be cool to figure out the volume, right? I mean, of course, you could take something and pour a bunch of liquid in, right, and then measure the amount of liquid. But another way you could do this, right, is you could build a bunch of very tiny circles, right? Let's say like these wafers, and you could just start stacking them on top of each other.
Well, that's assuming it's a snug fit, because then that's an
Yes.
estimation.
Yes, yeah, no. Assuming you could make these perfect circles, okay, and also that like they're really thin, right? Okay. If I wanted to figure out the volume of this thing by adding up all of these wafers, right? How would I do that?
You add up a bunch of wafers, and then after you
Add
get
up-
that, you times
Add up what of the wafers? What do I add up of the wafers? What about the wafers do I add up?
the width and the height.
Good.
Probably
The
maybe-
surface area. We add up the surface area. So in the same way, you know, like when you find the volume of a, I don't know, let's say like a rectangular prism, right? Have you done this before?
Yes.
What's the equation for this? If this is the length, this is the width, and this is the height, how do I find the volume of this thing?
Rectangular prism.
Uh-huh.
Look at
Nixie and Cade said it's
What
already
the
x cubed
length-
over 3. It
what
probably
the
is. We'll
length
check
and
it.
height, what the width times.
It's
height
length times width times height, right? Okay. But I want to show you where this comes from, all right? What you're doing, right? Width times height is what?
Width times height. That is it's the square something.
That is the surface area of this, right? Okay.
Yes.
And then what we're doing is we're taking those and we're multiplying by L of them, right? By that many.
how
like,
long they are.
good,
That
exactly.
gets you the volume.
Well, yeah, it's like the individual width of it times like how much total width there is there. Yeah.
But
Yeah.
once you get the surface area of one side, you just times it by how far it goes back or
Yeah,
forward.
by how many of these you need, right? Yeah, okay. So that's cool. This is how integrals work with volumes of revolution. The only difference here is that this surface area here is changing as I travel along like some axis. So as I travel along this way, do you see how the circles have to get bigger and bigger?
Yeah.
Okay. So this is where, okay, now the surface area depends, right, on where I am as I'm adding up all of them. And what integrals do, why integrals are so cool, is because I can say, okay, cool, if I integrate the surface area of one of these disks dot, let's say like dz, where dz is like this. That's the width of this thing. Do you see how this is the surface area, and then this is the height, or like the length, for instance, of this thing?
Yeah.
And then integrating it means, okay, but do it for all of those and make the differences between them like all infinitesimally small. Like that's why integrals are super cool. Okay. So it's a similar technique for doing this one. Okay. Let's think, What is, for instance, the surface area of one of these circles? What's the equation you know for the surface area of a circle?
You said surface area of a circle?
Yeah, of this disk. What's the equation for this area?
Well, we know that hold on, there's pi r squared, there's the circumference, there's
No,
the
no, no.
diameter.
No, pi r squared is the area, is what it is, right? Pi r squared.
Yes.
So good, yeah. So this has a surface area, right? Which is equal to pi r squared, okay? And then let's notice, right? R, right, is this. It's the distance from the center of this circle, right, to the edge, okay? Do you see that, Teacup?
Yes.
Okay. So, looking at here, right? Which distance here? Let's say I'm picking out this random circle right here, right? Let's say I'm picking this one, right? We're just doing this, okay? What is the distance here? What is the r here?
Well, it's the halfway point. The halfway point, yeah.
It's the halfway of the diameter, yes, okay. But on the graph, right? Let's say on the graph, right? Y
It's
equals
clearly
x
the
squared.
positive sides.
It can be whatever side. But like, what coordinate is this? What coordinate is this?
It would be a lot easier if there were numbers on that graph.
Well, there are no numbers. You have to just recognize, Teacup, that this is the x coordinate. Do you see how this distance here is the
Oh,
x
that's
coordinate?
what you were asking?
Yes, yeah. It's the
I thought
x
you were
coordinate
asking
of this graph. Yeah, it's
So
okay.
you're asking like, okay, it's at 1, 2, and it's at 2, 4.
No. There's no number on it because this also says c is what this says, right? Yeah, right. This is just c. So yeah, the important thing here, right, is that the radius here is the x coordinate of this graph, right? So when I'm doing my integral, I'm going to be, okay, cool, I'm integrating pi r squared, where the radius is now x. So I'm just saying, okay, that's pi x squared. Okay?
Squared.
And then we need a d something, d whatever. This, right, is what we refer to as like the width of, or like the thickness of each one of these shells, okay? Each one of these like wafer discs, which has to be in the direction, right? Has to be in the direction we're going up, okay? So what is that going to be? Is that going to be dx or is it going to be dy?
It's going to be dy.
Good. Yes, so this is dy, okay? And then we're adding up the shells, right, in dy from which y coordinate? Where are we starting to add our discs and where are we ending to add our discs in terms of y?
The 0 and then whatever the top is.
C. It's whatever c is, right?
Yeah.
See this? We're going from 0 to c. So we're going to do that on the integral bounds here. I'm going to say, okay, from 0 to c. So I'm going to add up the surface area, right, of a disk that has a right a radius of x and has a thickness of dy. Okay? This integral is almost cool. It's almost cool to do this. The only issue here is that I have two different variables. Do you see how I have dy and I have x? You can't do integrals when the variables are different, okay?
Yeah.
Okay. So we have to go back here and say, okay, do we know anything about x and y? Like, is there some relationship between the x coordinate on the edge of this bowl and the y coordinate on the edge of this bowl?
Well, it's always, I can't say that. I don't know.
Okay. We know this. Y is equal to x squared. That because that's what the equation of this line is. That this is the border of the bowl, right? This tells me that the y coordinate on the edge of this bowl is always equal to the x coordinate squared. Okay? So when looking at my integral here, I know y is equal to x squared. So what can I replace this x squared with?
Y is equal to x. Wait, what can you replace it with? Y?
Yes. So now this goes, exactly, very good. Yeah, Nixon. Yeah, this is just y. Okay? Now, this is a good good integral to do. Because we have only y's. Don't worry about the bounds. Yeah, I have a random sound. It's a random sound. It just picks up random noises. Okay, cool. All right, I can pull the pi out. So I have pi integral from 0 to c of y dy. Do you know what the integral of y dy is?
Y dy. Oh.
Yeah. Yeah, what's the integral of y? We got to remember how we do integrals and derivatives.
Well, we know what integral is. Integral is where you
Yeah, what do you do?
raise the
Raise.
power and then
Yep.
divide.
Then divide. So if it's y to the first, what is that going to become?
Y squared over 2.
Good. And then this is going to go from 0 to c, is what we say. So you just plug c in there and you plug 0 in there. 0 doesn't do anything. We don't really care about 0. So yeah, that gets you pi c squared over 2, and you're done. Math is crazy. Yeah. Nixie and Cade, did you get some of that? I saw you were saying something. You said set x is equal to 3. I don't think we don't have any 3s in here, but yeah, x divided by 2 divided by 2. Yes, exactly. Yes. Yeah. Raise the power, divide by new power. So if it's to the first, it goes to the second, divide by second, divide by 2. Yes, cool. Good job. Wait, is my bot working yet? Oh, now it is. Okay. One sec. Let me add one to Bob.
Bob and Jamarcus.
Thank you for that. Yes, one to Bob. Add a bond coin to Jamarcus.
You're welcome for that channel.
I appreciate that. Thank you. Okay.
I feel like you're gonna be like the most helpful person in virtual
I
education.
love I'm all here for you being the most helpful person. That would be great. I need more help, honestly. I need more help.
Music.
I'm just always looking for more help.
I'm built with the help. I am literally kindness itself.
We love that. I'm literally kindness itself. I try to think I'm kindness itself sometimes.
Wait, what happened?
We're doing your question. We're doing your question. I'm just pulling it in. Yeah, I know. He sees me changing the screens, and Ethan thinks I'm ending the stream yet. I'm not ending it yet. No. We're only at an hour 20.
Have a good day, Corey.
You too, Teacup. Thanks, man.
I have 5,000 coins.
Do you? You have like 100 or something, right?
No, not bond coins. 5,000 Twitch stream coins.
Oh yeah, the Twitch points. Yeah, we'll save them up. I'm gonna start. We're gonna start the tournament. They're probably gonna be useful.
Really? Now we're gonna have to save it up on that?
I don't know. You know me. I'll nerf it. I won't make it so that Sam can come in and just like wipe the board clean with channel points. I know you're in there, Sam. Yeah. All right. Cool. Okay. All right. You need help with law of sines and law of cosines. Is that what you need?
Yeah, but see that's a good. I was thinking like you could just give me an example and then you guide me through it. But I want you to give me an example. See if I can do it.
Oh yeah, that's exactly.
Since
I'm gonna do
I've
it.
learned all of them from one video.
Okay. I'm a fan of this.
Let me try.
Here,
Let me
here.
try. Let me. Just one thing real quick.
I want to find one that's like kind of fun. This is kind of fun, I guess. Whatever. Yeah, just show me that you know how to do it.
Right. So hold on.
So do this one.
Right then.
Yeah, just find all the sides, find all the angles. That's always what happens. The teacher says find all the sides, find all the angles. You know.
Really? Find
Yeah.
all the sides and the angles.
All the sides, all
I've
the
been taking
angles.
things-
All
right,
the sides, all the
hold on.
angles. Yeah, that's what you gotta do. Find all the sides, all the angles. Show me. You show me. You show me.
All right. So here's what the video told me. It's to ask myself, is this like a right angle triangle? No, this is not a right
No,
angle
it's
triangle.
not.
So we
Yep.
can't use neither. That's what we can't. We can't use neither Pythagoras' theorem or the SOHCAHTOA or trigonometry. Like
Right.
that.
Right.
So we're gonna ask, does this have an angle and a side opposite to each other? And yes, it does.
Okay. Cool.
And so we can actually use a sine rule for this.
Okay. Yeah. Let's use the sine rule. What's the sine rule say?
So we can try to find the side there. Could you label some stuff for me?
Yeah. Sure. I'll label this.
Like the sides.
Well,
sides.
I'll label this C, and I'll label this C, and I'll label this like lowercase a.
Hey. Oh wait, yeah. And
Right,
B
because it's
right there.
opposite angle A, and this is like lowercase b. Good.
All right, so we're trying to find a side, right?
We're trying to. Well, we have one of the sides, right? We have side B. Side B is 15.
All right, so then we find what is side C. And so if we're trying to find a side, they always have it at the top. So it's like whatever side B is, you put that at the top, divided by the sine of B, right?
Good. Sure.
So like 15 over the sine of 70 degrees is equal to
Oh, but we know what B is, right? B is 15.
yeah, that's what I'm saying. Like you could
Okay.
the
Good.
sine over, and
Good.
then it will be equal to
Mhm.
whatever side C is, which is just lowercase c, over the sine of 75 degrees.
Good. Yeah. Good. I like this. This is cool.
All right, and
And
then
keep going.
so that's a go. All right, so what I know of is we're not trying to find c over sine of 45 degrees. We're just trying to find c. So what we're gonna do next is that we're gonna multiply sine 45 on both sides.
Good. Let's do that. Yeah. We can have this one just multiply on this one. So we get 15
Well,
sine of 45 degrees all over the sine of 70 degrees is equal to C.
and then yeah, can I try to figure this out on a calculator
Yeah.
real quick?
Yeah. Go for it. Go for it. I'll do it as well.
All right. How many decimal points do you want it to?
2.
All right. 11.29.
Good.
That's what I get.
Yeah. 11.29. That's what I got.
And then we're
Okay.
trying to find angle A, right?
Yes.
You know, I'm wondering if I could still do this, but angles in a triangle always add up to 180. What if I just add the 180 minus 70 and
No, that's
plus
yeah. I
45?
think
What if I did that?
that's totally the right way to do it. Yeah. Yeah. You can
Yeah,
just do.
but what if they still want?
No, it's okay. When your teacher asks you to find the angles and the sides, if you see that you already have a 180, just do it.
All right, but yes, can I still do it the sine rule way?
You can.
All right, well let's do that then. And I'm pretty sure it's the exact same method as before. So don't we know side A already or not?
No, we don't know side A. We only know side B and side C.
All
So
right,
this is
well,
actually where law of sines doesn't work, right? If you're trying to find angle A.
well,
Because I
not
don't have the side and I don't have the angle.
wait, then that must mean that you use the cosine rule, huh?
Yeah, we could use law of cosines.
Okay, never mind. I'm scared for that. No,
No, let's do it. Let's do it. Let's
that's
do it. No, no,
disgusting.
it's not bad. It's not bad. Let's do it. Let's use law of cosines.
Well, here's what it is. I remember that if you have like two angles,
Mm-hmm.
but not two angles. If you have two sides between between an angle, then you can use the cosine rule. Or if you have all three sides, then you can figure out any one of the three angles.
Uh-huh.
But we don't have all three sides at all,
We don't.
so we need to use the other one to find find the angle, right?
Let me think here. Sorry. We could use the law of cosine. Again, I know the easy answer is just to add it up to 180 and find out what the angle is. I know that is. But I'm just saying, you can also use law of cosines here. You can use law of cosines on here. Use it on this angle, Ethan. Try using law of cosines on this angle.
But we don't have the side A.
Good, but I do have the side B, and I do have the side opposite the angle. That's why this will work.
Isn't that when we're using the sine rule?
No, this is law of cosines. Watch. So law of cosines, right,
All right.
says that, what is it? Is it c squared is equal to a
what?
squared plus b squared
Oh.
minus 2ab cosine c? Is that right?
Well,
think
if
it
you
is.
interpreted it like that, then yes, it is. How I would say it is like, well, you're correct. Anyways.
No, yeah, that's fine. Yeah, it's whatever. Okay. Okay. Do you see how I have side C? I have side B. I don't have side A. But I do also have the angle C.
Yeah, I see that.
So technically, I could solve for A here. It ends up being a quadratic equation, I think. Which is kind of
Quadratic.
messy.
Then there's no way.
Yeah, you're not
There's
really
no way
gonna have
they
to do
would give
it.
me that.
You're not. Yeah, you're not gonna have to do it. It's okay. You can do it. It is possible. It is possible. It's just kind of mean.
Okay.
All right, just fill in the angle. You know what the angle is here. What's the angle?
Yeah, 65 degrees. Just 65.
65. Good. All right. And then now what can
Yeah.
you do?
Surely we can still use the sine rule, right? Since
Yeah,
we can
yeah.
now find an angle. Find the side, sorry.
Yeah.
And could we use the B ones actually? Sine A and sine B.
Yeah, I mean, you just leave this one. Just leave it where it is, right? You're just setting it equal to another something over something.
Well, here's what I would like to do. It's like since we're still trying to find a side, I would do something like A over the sine of 65 degrees.
Yeah.
Which is equal to
Good.
Which is equal to 15 over the sine of 70 degrees.
15?
Because side B is 15.
Oh, yeah, sorry. Well, it's 15 sine of 65 degrees over the sine of 70 degrees.
Yeah, once you do the working out, then yes.
Oh,
I
yeah,
get that.
yeah, exactly. Yeah. Okay. So that'll give you an answer, probably, something.
Yeah. Hold on. Sine of 70 degrees, right?
Mm-hmm.
Alright, and I get 2 decimal points.
Mm-hmm.
Alright, I get 14.45.
See if that's right.
I think that's wrong.
No, 14.47. I think 14.47.
47. See,
47.
see, I just get a little confused. That's it.
That's
But
okay,
don't
dude.
worry. Mistakes happen for all of us.
I make mistakes all the time, dude. I made a lot of mistakes today.
Honestly, so there's no way you would take scores off of me if I wrote down 5, right?
No, you'd be fine. Yo, what's up,
Yeah.
Destiny? What's up, dog? Destiny's in
Yes,
college.
You think I'm gonna be ready for the math exam tomorrow?
I think you are, dude. I think this is great. I think. you
What's
know
up,
this.
Doctor? Can you hear me?
I can. What's up, Destiny?
Oh, shit. Hang on now. I can't hear you.
Oh, he's figuring it out.
1 second.
He's figuring it out. 1 sec.
There
What's
we
up,
go.
Ethan?
Now we're all good. What's up?
What's up? 1 sec. Let me answer Ethan's question real quick here, Destiny, and then I'll get to you.
Absolutely.
You're good. You're good. What's up, Ethan?
Well, there are some topics that I see that are coming on the exam. So there's gonna be like properties of angles. The 6 properties of angles you use to try and find imaginary angles. You know that?
Imaginary angles? What the hell's an imaginary angle?
Like you use your imagination to find angles. It's just kind of
Oh,
a little weird.
okay. That's a weird thing to ask in a math class. Like, what's an imaginary angle?
And then you'll
He's-
have Pythagoras' theorem. That's why you'll have Pythagoras' theorem. Like
You know
trig
that one.
ratios.
You know that one. Yeah.
Yeah. And then there is the sine and cosine rule, which we just did. Do you think I'm
Mhm.
ready for that?
Yep,
We only
I
did the
think-
sine. The cosine is gonna be messy.
The cosine rule's not that bad. I think you got it.
And then the last one is circle geometry.
We did that with your last question 2 days ago. That was this
Ugly.
fucking mess. Where was this? Where was this girl,
Yes,
dude?
we
This
get it.
dude. This
that's
was a mess. I did do it.
I know I'm a son of a gun for that.
That's okay. That's all right. It's all good. Nice. Cool. I think you're good, Ethan. Yeah. Practice stuff. Go over other homework questions, and if you need more help, send me a DM. I can always help you with them.
I want to
What's
ask
up?
you one last thing.
One last
Or
thing. What's
two more
up?
things I want you.
All right. 2 more things. What's
two
up?
more. I want you to pray for me and wish me good luck. That's all I want.
I wish you the best of luck for your exam, Ethan.
That's dope. Yeah.
Yes, dude. You're gonna do great. I know you will.
Are you, what is it? Something like calculus final or something?
No. He's in
Nope,
pre-calc. or
pre-calculus finals.
Pre-calculus.
This is
In
pre-calculus.
Belize. In Belize.
In Belize.
Belize.
Very cool.
Better Belize it. Yeah. Nice,
Hey,
Ethan.
see, that's a good. Can you believe how a Belizean has come here and is trying to help others? Like
I think
I
it's a
might be
great.
the only
It's
Belizean in this-
You are the only Bleez in here. Well, no, a couple of your friends are in this Discord, but they're not nearly as active as you are.
Nope, they're nowhere close to me.
Yeah. No, you're doing great. I'm very proud of all of you've accomplished and excited to see what happens in your life. It's always kind of fun to.
Honestly, I have to go. I wouldn't even know where I was if I wasn't here with you.
Oh, that's so nice. We like that. Yeah, dude. We got you.
Like as always.
Always. Nice. Okay. Good luck on your exam, Ethan. Hope the best. Come by for the stream on Friday. We're gonna have a cool special guest.
I'll try my best.
Yeah, try your best on the test. What's up?
See, the thing is, Friday is the end of the exams. All right. So.
Oh
I
yeah,
should
so
be able to
party,
attend
celebrate.
there.
Yeah, just celebrate after that, dude. Yeah, hell yeah. That's what I would do. If I finished an exam, I'd be out partying afterwards.
Okay.
It's like I'm done.
Well, I guess I'll see you later.
All right, see you, Ethan. You're good. What's up, Destiny?
That's dope.
What's up there?
How's
Winter
college?
break
Did you go?
is coming to an end very shortly.
Oh, you're not back at college yet?
No, I'm not. I'm actually home right now, which is nice.
Oh, I hated being at home my first semester for Christmas break. I was like about to like kill myself. I was like I was like, get me back to college now.
No, I definitely like being home just because I especially got a very good relationship with my mom.
Oh,
And
nice.
so
Okay.
It's been nice being here with her, and I haven't had to work too much. Like, well, rather, I've chosen not to work too much since I worked so hard for
There's
Grace.
always this like honeymoon period, right? Of like you go home and your parents like, "Oh my God, we're so glad to have you back," and it's like 3 days, and they will do everything for you. They're like, "Oh, do you want this? Do you want this? Do you want a cookie?" Blah blah blah. I'm like, "Oh, nice," and then by like day 4 or 5. Then they start asking, oh, yeah, so we need to mow the lawn, or we need to put up this fence, or like, we need to do this. And I'm like, no. I liked it when it was just, oh, we're glad you're back. Then it becomes, no. Now you got to earn your rent or earn your keep or something. And again, I'm fine with helping out my parents, but it's just too funny the shift that happens after a couple days. Yeah.
Yeah, no, that's true enough. I mean, like, because my mom goes to work and I feel bad because I'm home and I don't have my car right now because my car blew up while I was away because somebody else was driving it, which was awesome.
Was it one of your
so I haven't been able
siblings?
to go to work too much.
Did one of your siblings kill your car?
Stay-at-home mom for her now. Like, I'm going home and I'm doing the dishes and I'm doing laundry and
Okay,
stuff.
okay.
It's actually really nice. Like, that's the kind of labor that I can get behind. You know what I'm
There
saying?
we go.
Like, it's just,
You could be a
it's
stay-at-home
easy.
dad or something, dude.
Honestly, I'd be fine with.
I said I'd be fine
with
as a
that.
stay-at-home dad too. The only problem is like girls just don't like stay-at-home dads.
Yeah,
don't respect you.
Unfortunately, not.
They don't respect you. They're just like, what?
No, it's honestly, it's fine. I'm realizing, like, you know what I've been doing with my time while I've been on winter break?
What? What have you been doing? Let us know.
So I realized that medicine is like totally for me because what I've been doing is I've
Cool.
actually like of my own free will and volition.
Yes.
I've been watching this medical show, Dr. House. I don't know if you've ever heard of it.
Oh yes, of course. Wait. House MD is it called Doctor House or is it just called House? I thought it was just called House.
It's House MD, but I misspoke.
It's just called House. Yeah, this is an old school
Yeah,
show,
yeah.
bro. This goes back to my days. This is I grew
dude,
up.
I was born. Literally, there's an episode where they said the date in the show, and it's like
Yeah.
the 4th episode. They said the date in the show. It's 2 months after I was born.
Yeah,
Yeah,
House.
I was around like 5 years old watching it with my mom. It
Yeah,
was so
House.
cool.
Yeah, bro. What? Yeah, 2004 to 2012. Yeah, this is when I was 14 to 22. Yeah, this is my
Oh
TV.
my God.
My TV era.
Yeah, you were 14 when I was born.
Yeah.
It-
I was
it
probably-
started-
I was doing the
So
same
weird.
shit,
I did not
dude.
make-
I was on a
I did
computer.
not mean to make you feel old at all. I'm so
No,
sorry.
it's okay. I'm super old. Okay.
Jesus. No,
All right, so you've been watching House. House is a cool TV show. Yeah, everything is
So
lupus,
what
right?
I do is I hear terms, and then I'm literally just writing them down on my phone, and I'm making a big Quizlet of them.
Nice.
And so now I'm like educating myself on a formal basis. Like I'm realizing that I actually really miss like being educated in anatomy and physiology and all that
Okay.
stuff. And I really want to get back to it. What I'm really excited for is I'm taking nutrition, microbio, and then anatomy and physiology 2 at the same time next semester.
Okay.
Meaning all that stuff is going to link up in a lot of ways, which I'm very excited for. And I've already taken nutrition,
Uh-huh.
but that was like a county college, so I imagine it's going to be a little bit more intensive just because TCNJ has a really great nursing reputation and
Sure.
it's a nursing like class and the abbreviation. So I mean, I imagine it's going to be a little bit higher level. But like, I already know a lot of this stuff. You know what I mean? Like, and I took general biology my
Mhm.
senior year, so it was like, and we did a lot of nutrition and like digestive system stuff then. So I'm very excited. In other words, like I'm so looking forward to seeing how everything interconnects and all that stuff. And it's like, while I've been home, I was such a loser for like 3 straight days from Sunday
Bro, you
Sunday
just gotta
morning.
chill. You gotta chill sometimes.
No, you don't understand, dude. Like, hang on. So I was Sunday morning to last night, meaning like
Yes.
Sunday morning to Tuesday night, 3 straight days. Literally, like 90% of my waking hours, and that's probably not an exaggeration, was spent playing Legend of Zelda.
Oh, okay.
Like,
Some classic.
the entire time.
Wait, the N64 one? Which one? Which Legend of Zelda are we talking
Wind
about?
Waker, which was originally made
Oh.
for the Game Boy and then was remade on the Wii U.
Yeah, when I hear Legend of Zelda, I think of the N64 Legend of Zelda, which we had like Majora's Mask and everything. Dude, yeah, this is
Breath
how.
of the Wild.
Yeah, this is
Yeah,
it.
that's-
This is the OG one, dude. Oh, it was a gold cartridge. Oh, that's dope. Like that. Yeah, this
Yes,
is.
it's
Oh, apparently there's.
I have
that's
Wind
wild.
Waker. Jesus, that stuff's gonna be worth a lot in like 10 years.
Yeah, right. Okay, Wind Waker I know is yes, that's the
Isn't
GameCube.
there a new one that came out?
But they remade it. Well, the newest
Yeah, they
one
remade it
I
for
honestly
Wii.
don't even understand because like it's like Roblox. You're like building shit and stuff, right?
No, I mean, yes, but no. Like the graphics that you see, it's essentially all that. And you go around talking to people, and you sail in an ocean. They're actually considering remaking. What is it called? Wind Waker again for the Switch, or maybe the Switch 2.
Yeah,
which is
I thought it
rumored
was,
to come
dude. I
out
thought it was
in,
just like you can make like cars and stuff.
No,
Yeah,
that's
it was
that's
in
Tears of the Kingdom.
Oh, Tears of the Kingdom. Yeah. That's what I'm talking about. This is the latest
You
one,
can
though.
build shit in Tears of the Kingdom.
Yeah, dude. Look, like people build like laser turrets or like a skateboard. It's more
God.
it's more Robloxy or more Minecrafty. I thought.
Yeah, no, that's Tears of the Kingdom, which is totally different from Wind Waker. That's actually the sequel to Breath of the Wild. It takes place in the same universe.
Oh, okay.
Let's go,
Very
bro.
cool. What's up,
As soon as I
Ethan?
see them- As soon as I see these Nintendo games, I just gotta jump back on immediately. What are y'all searching about?
He's talking about he played a lot of Zelda when he was home for Christmas break after college. That's what he's talking about.
Honestly, yeah, I did play Zelda Wind Waker and TOTK, but Tears
Tears of the Kingdom. Yes.
But I never got the experience with Wind Waker again. It's like I would actually want to play it again. I can't
Dude,
remember.
wait, hang on. Can we just collectively agree that Wind Waker was actually shit? Like that was
Wind Waker's no
listen,
good. He likes Wind Waker apparently.
No. I think Wind Waker is terrible. Like oh god, dude, I can't believe I spent
Oh,
72 hours
Genshin.
playing
What's
that game.
Genshin? What's
They-
Genshin, Nixon?
They poorly designed that game so hard. The map had like 4 islands on it. It was the worst.
Honestly, the boss battles were really cool though. It's like
Yeah, the boss
Did-
battles were great. Boss
Yeah,
battles were
Genshin-
great.
Oh,
Ganon is-
Genshin Impact is a game that's similar to Zelda Breath of the Wild. Oh,
that's the thing. I got a question for you.
That's cool.
Yeah.
Do you remember all the 4 bosses that were in Wind Waker?
Yeah. So we got because I just played it, and I just played Ganon's Tower, which is where you face all 4 of them again.
Ganondorf. I remember
Ganondorf
that.
literally
Dude.
hit me.
I was so mad at the Ganondorf boss battle. They force you to use a mechanic that they only teach you once.
Wait. Oh, okay.
What?
Genshin Impact came out. in
It's only
2020.
required to be utilized one time, and it never comes up again in the game. I had to Google search so much stuff when I was playing this game because it's so poorly designed to push you in the wrong direction. Like, what they
You don't know how
everything that
lucky
they-
you guys are to have Google for like walkthroughs.
Yeah.
You're saying like, oh, this boss is hard. Let me see how to do it,
No, no,
bro.
no.
When I
literally
played video
walked
games,
through-
dog, we had to go to the library and get a fucking book.
Oh,
Like,
yeah. Oh, I know.
yes,
No, I
dude.
remember you guys-
There's a thing called Prima
you guys
Guides, dude.
played GTA
Literally
you
these.
guys played- You guys played GTA 5, and literally you had to
GTA
write
3,
down
dude.
all
I
your
played like
game
GTA 3,
codes.
dude.
GTA 3.
Yeah, dude.
Jesus Christ.
Dude, I remember
San
trying to
Andreas is
be
much better.
I remember trying to beat Tomb Raider, and I had to literally buy like a fucking like book to beat some of the levels because you just
Oh,
you,
no, bro.
yeah no bro. Let me show you the inside of this book, dude. Like, oh, I hope they show it, dude. What? Oh, show me the inside of this book. But they would have like pictures of like, then you go to this, and then you do this, and then you click this button, dude. It was too funny.
Oh wow.
That's
I want to be
hilarious.
inside of it. I want to be inside of it.
I don't want to be inside
Now,
of it. Yeah.
the only thing that I had to look up, I looked
Pause.
up two things. I looked up where to go to find the ghost ship, like where to
Mhm.
go to unlock the map for the ghost ship. Nothing else, just where to
Ghost
go,
ship?
which island to look for. Because what's so terrible about Wind Waker is that there's so much time that you waste just going to islands because the ship is so freaking slow. And I had to look up how to find the speed ship, like the speed sail for the ships, that it wasn't so freaking slow. And the only way that you can continue in the game is by happenstancing upon this tornado in the middle of the ocean. You gotta fly into it, not even avoid it. You gotta fly into it just to discover this mechanic that you cannot progress in the game without. It's the
That's
stupidest
crazy.
thing in the world.
Dude, what is
That's
sorry,
so-
what is this family gaming database? What the hell is this, dude? What? Family gaming database? Dude, what website have I like stumbled upon here, dude? What?
Yo, what dark web are you?
Dude, what is this? I just wanted this. I wanted to show you guys. Like I had this book.
Yeah.
I literally had this book, and this was
This
like,
exact
for instance, I had this exact book for this exact Tomb Raider, and it would say here. It says, look, light a flare before you go through any further, then start walking, then do this, then do this, and it would have pictures of what to do in the game. You guys just watch a YouTube video, which is super nice. But I remember seeing this. I'm like, wait, how the fuck did they do this? Yeah, it was super
So you
crazy.
could go down to your library and buy that book for 12. You couldn't even rent it. You had to buy it.
I had to buy this book. Yeah, I remember having to buy this book because I would get stuck. I would get like Tomb Raider was kind of a difficult game at some certain parts, like because Tomb Raider involves a lot of puzzles and a lot of
Right.
kind of like hard
I played,
boss
I
battles.
played Tomb Raider. I played the newer Tomb Raider, like the one with not, well, obviously the one with Lara. It was the one on.
I know what you're talking about. Yeah. The
I forget. It was.
They did remakes of everything.
was
And whatnot.
recently.
It was all good.
Destiny?
Yeah.
So, if you just went for the 4 boss battles, which one's actually your favorite?
Which one was my favorite? Ooh, okay, that's
Like, all
hard.
those- like there
Um,
was like a plant one, a dragon inside of a lava, like a
Yeah,
dragon that was.
I know what you're talking about. I actually like the dragon the most, in the one in the lava, which I think of it more as a scorpion. Because
Well, yeah,
that
it
one
does
was
have those
like,
sensors.
I feel like there's a specific point at which a level is the perfect level of difficult for it to be enjoyable, so that you actually feel like you did something by figuring it out. It's not just the labor. It's like you do XYZ and then you're done. Like, rather than like, oh, I figured it out. I have to cross 4 oceans to get to this island and then come back. And it's like, it's just, it shouldn't take that much time to execute the thing that you conceived of. And that's what I think that Cocoon did really well. I don't know if anybody's played Cocoon.
You want to know my favorite boss?
What's your favorite boss, Ethan?
It's like the dragon that opens its mouth when you're in the sun. It's like creating a sun hole.
Oh yeah,
and it's
yeah,
like-
yeah. The sandworm. That was the one at the Wind Temple, and that one I was considering that was my favorite, but then I'm like, well, that one was a little too easy to figure out, and it's too easy to complete it once you figure it out. Like it's you just grapple it with the hook line thing, and then you just hit it, and it's like I don't think there's any real challenge in that. I barely had to try for that fight.
But it's just the music. The music is really giving you the courage to fight that. That's what made me love it. The
You know
Scorpion
what my
one.
favorite game was though? I think there is no better game in this world for like for puzzles. Not just, we're not talking about story, we're not talking about whatever, just the pure enjoyment of figuring out what the heck you're supposed to be doing, than Pikmin 3. Pikmin 3
Dang,
was the
Pikmin
peak.
3, boy. I love that game. I literally
Actually, they made
played.
Pikmin 4. Like 3 years too late for me. I'm so mad. They made Pikmin 3 in like 2013, and then they made Pikmin 4 in like 2023. Like, bro, we were waiting for too long. Like,
I remember the OG
Wait,
Pikmin
did
coming
you
out, dude.
actually- Did you
All right,
actually
one
play
sec.
Pikmin 3?
I do love the discussion. I do have to go teach in like 10 minutes though. Sorry. You guys can keep talking about whatever, but let me end the stream. Let me end the stream. You guys can talk about whatever you guys want, but I gotta go teach.
My question.
What is your question here, Nick, dude? What you asked the same question you asked last time. You can't do that.
Yeah, because like I need more.
No. Okay, here. Let me end the stream real quick. All right. Thank you everyone for coming to Office Hours. Had a great time talking with all you guys, going through math stuff, science stuff, video game stuff. It's all great. I love all of it. Sorry, yeah,
We love you,
sorry.
Dr.
Next
Gold.
time I'm first, yeah.
You can be first next time. Yes. Well, okay. So this is the
Thank
last
you.
office hour stream of the week. So our next stream is gonna be on Friday, and you might be interested in this in this Destiny. We're gonna have a special guest for the podcast, and he's a video games tester. So he manages like
Ooh.
he's worked on some pretty big ones like Halo, Warzone, Call of Duty, everything. Yeah.
Ooh.
So
And that's this Friday or next Friday?
this Friday, that's going to be at 6 p.m., so an hour later. So that's around this time, but 50 minutes minutes earlier from now.
Okay, yeah.
So-
Wait,
so you-
hang on, wait. I'm not in your time zone, so
Yeah, so that's 9:50 your time right now. Yeah.
yeah. It's 9:50.
So it'll be 9 o'clock. 9 o'clock your time. We're going to start it on East Coast. Yeah.
okay.
So yeah,
Legit.
Ping me, please.
I will. I'll ping. So
I
I'm going to make an
will.
announcement in the thread. In the Discord. I'll make a big thing for you guys to pre-submit questions and topics you'd like to go over, and then we'll try to get through as many of them as we can during the AMA, and then I'll have him pick which question he liked the best, and we'll give out some gift cards
I'm
and prizes
thinking
and
about
stuff.
being a game tester.
Yeah,
You know
that
what?
would be cool.
Yeah, that'd be a good time to ask him questions.
Let me see. Let me see.
Ones.
Yeah. Okay.
You know
Cool.
what? I mean, that's the sad part. Like the great thing about being games tester is you play video games all day, but the bad part of being game
No,
tester is
he'll
you play
talk
video
about
games all day.
He'll talk about it. He'll
Yeah.
talk about it. So yeah. So if you want to, please come by the stream on Friday. This will be a lot of fun. He's a good friend of mine, and I'm gonna start doing this every Friday. We're gonna have special guests for the AMAs.
I would love that.
So yeah.
Let's go.
What's your end goal for this, Dr. Gold? Like, what is
What's
your
my exit
vision
plan?
for
What's my
wherever-
exit plan?
Yeah. Not your exit plan. I mean your end goal. Like, what is
My
what
end
the-
goal
what the-
is to scale this. I want this to happen, but with more of me's basically. Like, there's only so much
Oh,
of
yeah,
me,
yeah, that makes sense.
right? So I want this to be able to run, 24/7, 365 across like 10 or 20 different instructors, and there to be enough funding for prizes and stuff to support, I don't know, 10,000, 100,000 students. Right now we support around 1,000. It's cool. But like I'd like to get up to like 10,000, 100,000. I think it'd be cool. That's my end goal. And the end goal is to scale. I think what I have works. It's great, but we need to scale it. And so that's my next next problem.
I can
challenge.
start clicking into your Twitch stream if you want for like viewership stuff.
Yeah, that helps. That helps. Yeah. All the views help, all the metrics help. But yeah. Any ideas you guys have is great too. But
Yeah, I really love when we had the music guy come. That was actually really,
yes,
really
the
cool.
music. A lot of people said that on the end of the year
I
survey. They
missed
really liked the music stream. We'll do more of those. I'll do more of those. Yeah, because I have
By
a
the
lot
way,
of really fun
guys,
music
I don't
friends.
know if we ever ping this in here, but I have a whole server for sharing, creating, and giving advice on music stuff, and I've got some
Oh,
actually really
please.
talented musicians
Yep.
in there.
Put it
If you guys
in
ever wanna
the
come in
bulletin board. Do you know what channel we have? We have
I'll
a
join.
channel for that. It's called Bulletin
Yeah,
Board
let me,
Self Promo.
Let me
Yeah, put your
let me,
Discord
yeah,
put
yeah.
your Discord link down there, and then that way all the other students and I can join it.
Okay, yeah, we'll do. Let me just paste that right there.
Yeah, paste that in.
Wait, where is the bulletin board? Is that in extracurricular?
Extracurriculars down at the bottom.
It's all the way at the bottom.
Yeah, it's right next to art gallery.
Code, photography. Oh, there we go. Bulletin board.
I
Okay,
tagged
cool.
you. I tagged you. There it is. So yeah. If you want to keep sticking around and learning some more math, we have another streamer called Danny Highway. He's a cool guy. He does more advanced math classes and whatnot. So if you have math questions, stay in the stream. And we're gonna raid his channel. He's a cool guy. I resonate with him. He also hates geometry. So I'm like, yes, I'm here for it. Otherwise, I will see you guys on Friday for the AMA. Until then, enjoy the rest of your Wednesday. Enjoy the rest of your Thursday. And I will see you guys on Friday. Cool?
Later.
Peace.
Thank you for doing this. If no one's told you that lately, by the
You're
way.
very
really
you're very
cool
welcome, dude. You're very I appreciate it.
Yeah.
Dude. Yes. Love you guys. All right. I'll see you guys.
Actual education with the raid. Thank you, sir. I appreciate you as always. We're working on some probability right now. If anybody's interested.
Yes.
Silvio, actual education is another math streamer. Like the list is huge. If you look at my Discord, I think everybody else has a list by now already as well. If you look in my Discord server, there's just a list of all the people that you should check out that do math on Twitch. Actual education is definitely on that list. I think at the top of the list actually, because And it's definitely growing. So now, Chris, the way that we have to figure this out is a bit annoying because last time when we had a probability that we didn't know, we just had to subtract a bunch of stuff from 12. There were like 12 balls in the bag. We knew what 8 of them were. So we just had to do 12 minus 8. Here, we don't know like how many different outcomes there are. We have actual decimals. So to find a missing probability from a data set,